When we talk of reimagining Indian science, it's interesting to ask, what do we think of Indian science in the future? What sort of shape would we want it to take? Will it just look like what we have currently, just scaled up to larger proportions? Do we imagine it to be better integrated with the science that is done worldwide? Or will we have the opportunity to reimagine it and to change it altogether? What parts of it could we change, if we could change? And what should we think about? From outside, Indian science looks very much like the practice of science in other countries. We have a large university system, we have research institutes, we have a strong space and nuclear program, we have an extensive agricultural research program. Look further, look more carefully inside, and that's where the cracks begin to appear. We turn out graduates in large numbers, but not all of them are employable at the level that we would like them to be. Not all of them are creative, independent, individual members of the community, as we would like them to be after having achieved a certain level of education. That's where it's important to think about how we could change the structure of science. And what I want to discuss is what we've learned from the COVID-19 epidemic in terms of this question. There's no doubt that India, as well as many other countries of the world, have been through an experience that is unparalleled, at least in the lifetimes of anyone who lives in this country. This is a good time to think about what is it that we can do given what we have learned so far, and how we should reimagine what we have so that we can construct a better future for us and for everyone else in this country. So as I said, COVID-19 has given us an opportunity to think about many of these questions more carefully, and it's important to realize the crucial role that science has played in our understanding of COVID-19 and our ability to deal with it. We have done things that we never thought would be possible. We have developed vaccines within a space of a year, when the normal timescale for develop a vaccine is 20 years or so. We were able to identify the causative agent of COVID-19, the SARS-CoV-2 virus, within a space of about 5 or 6 days to figure out the sequence of the DNA of the RNA molecule that was inside it, and turn that into a device that we could use to swiftly diagnose cases of COVID-19 when they appear in the community. These are things that we could not have anticipated earlier, that we would be able to do things at this scale. And in order to do this, one required input from pretty much every branch of science to come together, large amounts of government support, and indeed a very, very strong focus on what is it that science together could do for the community in the face of this incredible disaster. In the background of the pandemic, here are 10 points that describe how I think about how we might reconfigure Indian science for the future. There may be some disagreement on what these points are, and someone else might come up with a different set of points, but I nevertheless hope that there will be some level of overlap in what I think of and what you might think of as a scientist or as a member of the lay public. My points are centered around what we would like our society to be in the future. What is the India that we are looking at? How do we create a more fair, equitable society where the rights of everyone is taken into account? And for that, how do we restructure our scientific system, our educational system, in order to achieve that goal? So my first point is, understanding the role of science is crucial to becoming a better citizen. By better citizen, I don't mean someone who is just mechanically obeying the laws of the country as they might be, but someone who thinks about why they are and how they help to protect the rights of everyone in this country. To do that, one must introduce scientific methods and scientific ways of thinking in the way that we deal with the world. When I say scientific methods of thinking, what I really mean is understanding the role of evidence. That is the center of science, to understand how does one accumulate evidence, how does one make sense of that evidence, and how does one act upon that evidence. So evidence-based medicine, evidence-based science, evidence-based policy is central to these questions of how one makes a better citizen, how one conceptualizes the role of a citizen in a democracy as someone who is able to make their own independent decisions, to be independent in their evaluation of what happens in their democracy, and is able to proceed further using science to integrate the information that they might receive. The common superstition that looking at an eclipse harms pregnant women. What evidence is there for that? What happens in regions of the world which may see an eclipse versus those who don't see an eclipse? Is there a difference between them? How would we test it? These are questions where science can actually contribute by contributing a methodological understanding of what can be tested and accumulating evidence that tells you how to behave and what parts of knowledge one can discard because they are simply untrue and what parts of knowledge are important because it's supported by a base of evidence. The second important point that I think is particularly crucial now in the background of the COVID-19 epidemic is that we must break the barriers and boundaries between the different sciences. In order to understand COVID-19, there were many branches of science that had to come together. Certainly genetics, that describes the code, the RNA code of the virus. Certainly techniques in physics. For example, they developed electron microscopy that could tell you about the structure of the coronavirus and identify this virus as a particular type of coronavirus. There were methods in vaccinology, methods in clinical medicine that enabled the treatment of COVID-19, that suggested what types of treatment might work and what might not work. In order to do this, all of these different approaches that drew from each other, the PCR test was devised in a completely different context, but is now commonly used in order to find out if you suffer from COVID-19 or not. But they were developed initially to understand the behavior of bacteria from hot springs in extreme conditions and how these bacteria were able to generate many copies of a sequence. The breakthroughs across these sciences are important, but it's also important to understand the relationship of the sciences to the social sciences. That's another barrier that one must break. The sciences cannot exist on their own. They exist in a context. And part of the science is also the ability to communicate the results of science, the importance of science, and the philosophical thinking around science to the lay public, to the public at large. So in order, again, as I said, to become a better citizen, it's not sufficient to think only about science. One must think about the social impacts of science and the social consequences of that science for the public at large. My third point has to do with the importance of local community-based concerns and needs centered around ecology, sustainability, and conservation. There are parts of India that are among the most biodiverse in the world, even though they're being eaten at by various types of commercial interests that would tend to shrink them. Now, more importantly, more than ever before, it is important to be cognizant of our ecology, of the rich diversity of life that surrounds us, not just for reasons that we might choose to plunder them at some point, which certainly is a bad reason for that, but because they may supply to us vital sources of new drugs, of new medicines, of new knowledge, of new potentially inspirations for constructing things, man-made objects that derive their inspiration from biological systems, from living systems. In order to do that, one must start with the community and the problem that the community faces, the local problems, its conservation, in terms of pollution, every problem that surrounds you in the community, then move outward to a larger extent to see where these problems affect the district, the state, the nation as a whole. So rooting these in the local community is an important part of what science can do. Again, using evidence that is gathered from observations of the community, from observations around you. And these can be done at any age, starting from the young, going all the way to the old, because it's simply a matter of amassing information and making sense of that information using a base of evidence. My fourth point is an expansion of my third point, the concern for local communities and ecology and sustainability to the whole world. The problems that the world faces with global warming, with overfishing, are problems that are not problems of any single locality. They're not problems of America versus India versus Russia versus Japan. These are wicked problems because they involve the interaction of many, many different factors. And there are many, many combined interests, all nominally very different, that intersect to create these problems and could potentially have to be involved to solve these problems. It's impossible to think of climate change as a responsibility just of one country. No country can keep its pollution to itself. Pollution of the air, for example, circulates around the world. Changes in our climate can originate in parts of North America, but then very rapidly spread to other parts of the world. It's our responsibility as a nation to be aware of our own part in creating these large global changes to our climate, to our environment, and understand our own role in contributing to that, as well as our own role as being part of a global scheme that sets these matters in motion. My fifth point has to do with the importance of reimagining our approach to health and disease. We have been currently through a pandemic the likes of which the world has never seen before, and that more than anything else has emphasized for us the importance of a good public health system. India is home to the largest number of stunted children in the world. We are home to lots of exotic, neglected tropical diseases, which are not the interest of, for example, Western populations, because they don't see these diseases. If India does not solve these problems for itself, no one will solve these for us. Let me also describe the importance of involving communities in this effort. How do we become sensitive to a new disease that appears somewhere? At what level can community participation help us identify what might be happening, the signals of a new fast-spreading disease in a particular location or a locality? To what extent can communities partner with a good public health system to provide an early warnings of what might be happening in the future? To what extent can communities be involved in the science that leads to those outcomes and the science that leads to understanding public health and the determinants of public health a little better? Because these should be community concerns. A community in Gujarat is not the same as a community in Tamil Nadu, is not the same as a community in Bengal. To involve local communities in constructing the nature of the public health systems that they would like to have for themselves, to ensure that good public health is available to any citizen of India, wherever they happen to be. This should be an important thing going forward in determining the nature of science and the nature of medicine as applied to our population, and what we should reimagine in the future for what it ought to be like. My sixth point has to do with the nature of appropriate science and innovation. Let me give you an example. The foldscope is a remarkable invention. It was made by an Indian scientist based in the US, and it is a little microscope that you can construct essentially out of very simple components and put together very, very cheaply. This is a microscope that enables you to do as much as a regular microscope at a much larger expense made of metal, which you might buy in a shop, and is of course out of the reach of many of the students in our population. So the foldscope is a remarkable example of appropriate science, of science that can be taken to the public, a science that is useful to the public in rekindling a nature and awareness of the joys of understanding something new, of seeing something that you have not been able to see before. How do we think about science in this appropriate way in a country that is developing, in a country that is poor? How do we go away from looking at big science as being the only science worthwhile of doing? And how do we look at extending this freedom to look scientifically at problems to every citizen in the country? And I think the way there lies in discovering appropriate science, not big science, but the right size of science, small science, that involves things that anyone anywhere can do in the country. My seventh point relates to the importance of mathematics. This is often ignored in discussions of science, but there's no doubt that an understanding of mathematics and a love for mathematics lies at the foundation of pretty much any science that you can think of. It lies at the foundation of a GPS system that you can use to orient yourself wherever you are, happen to be inside the country or around the world. It is part of diseases, for example, to predict what might happen to a disease such as COVID-19 over the next week to a month to a year, of understanding the nature of how the virus might change, how different variants might appear, and which might be more serious and which might be milder. Mathematics is the bedrock of all of these sciences, and taking mathematics and removing the fear of mathematics in young children, in older students, and even across, again, even with adults, is something that is an important thing to do for our country. And that's my seventh point. My eighth point is the bridging between basic and applied science. When we think of science, we often think of basic science as the important science that has told us so much more about the world that we didn't know earlier. But basic science is of no use unless it has something to be applied to, and applied science can only function on a profound basis of good basic science. So while we should continue to support basic science in this country, it is important for us to also establish the connect to applied science that can be taken to the people, can be used in ways that are appropriate to our country, that are appropriate to our communities, thereby show people what the uses of sciences might ultimately be and why it is important as a societal function to support the practice of science. My ninth point may seem a little unusual, and that has to do with the relationship between science and religion. In a country where more than 90% of people believe in some form of organized religion, it has traditionally been the job of science to stay away from questions that have to do with religion. But it's important for science to understand what is the role of science and what is the role of private belief. And scientists, more than anyone else, should also be cognizant of this boundary and able to present this in a way that establishes what science is all about and how it does not interfere with private belief. This is important, especially in these terms, where where often these are posed as a conflict, whereas they should not be understood as a conflict, but the difference between what can be established using a knowledge base and what really is a private observance. My last point is probably my most important point, and that has to do with education and reimagining education and the importance of teachers. None of this can function. None of what I have said is even remotely possible if we did not have teachers who supported the practice of science. It's important to train good teachers, it's important to support good teachers, it's important to empower good teachers, it's important to teach teachers about the frontiers of science and where science is actually going. We should pay teachers better than we have so far because they're fundamental to creating the new generation of people. Teachers can create students who can think for themselves, who are independent and have the potential to become citizens of the type that we would like to encourage. Thinking citizens, conscious citizens, aware citizens, who are aware of the point of the place that they have in a democracy. Again, this may not look like science, but it's a crucial bedrock of science to create the sort of people that we want in the next generation, in the coming century. We have traditionally as a society valued credentials over actual learning, and this is something that again we should go back to our basics in that. What are children learning? What are young people learning? How do we make sure that they incorporate the principles and the ideas of science in what they're learning to make them more independent and on their own? I think this is, as I said, the most important of their points, the creation of good teachers and the understanding of the value that they bring to our society.